Moving forward with Xen installation, now that we have our bridge in place. So, some concepts to keep in mind. Consider using LVM for storage flexibility, even if, let's say, underlying hardware is RAID, or let's say some super fast bus path such as fiber, etc. LVM, at least overlaid on these underlying technologies, will give us the appropriate management semantics to flexibly move our storage around. Now that comes to mind, of course, is in addition InfiniBand, etc. So regardless of the bus architecture, consider using LVM because you can move things around rather flexibly. Also, leave ample partition space for the various VMs or guests or DOM-Us. So within your LVM partition, let's say the volume group is 100 gigs, and you partition, let's say, per VM X amount of gigs, segmented in such a way that there's ample space to readily, whether via script or manually, provision those additional storage entries. Now, let's just note that the installation of Xen will update the following areas of your system, including the default kernel to a Xen kernel, and numerically it'll appear like your existing kernel. So for example, from the shell in this remote system, a uname A, for example, shows that the current kernel 3.20.23, this can be updated, it needs to be applied, but nonetheless the Xen kernel will be similarly matched, but this is not a Xen kernel. You'll see momentarily why. But your kernel will become a Xen kernel, and this is where, as we've mentioned earlier, that there's the interspersing of the tier 1 hypervisor. By replacing your base kernel to a Xen kernel, your system, your overall host, now becomes a tier 1 hypervisor. That kernel now has access, the Xen kernel that is, to physical hardware. So tier 1 physical hardware access. And from there we can spawn the various DOM-Us, and this will position the main system into its own DOM called DOM0. So for example, if we had the tools that we'd do XMList, and you'd see, well, it's currently not installed, that the main system is currently not in DOM0, but will be placed momentarily after. So tier 1 physical access, this places host into DOM0, and we should also note, and prepares to host guests or DOM-Us. In addition, the grub configuration will be updated. This will do manually to load the Xen kernel, unless you have a tool that does it for you. By default, grub will be still instructed to load the standard kernel that's on your system. For us, this is 3.20.23. The latest is currently 41, but we'll have to update it accordingly to load the Xen kernel. Now, insofar as the installation, well, there are some prerequisites, so let's go ahead and install Xen. We'll get the prerequisites first, including Python LXML. We've already taken care of bridge utils, so we'll do an aptitude install Python LXML, and this is required to generate configs for Xen. So we'll ensure that this is on the system. You'll see errors if you don't install Python LXML. Let's get that going. And we should have that momentarily. Bridge utils is already installed, so bridge utils already installed to facilitate bridging. And last but not least is the hypervisor itself. Aptitude install Xen hypervisor. Let's pick out the version that's available. Should be 4.1, but let's do an aptitude search. Xen hypervisor, for example. See what comes back. I'll regex search it. So the primary version for us is 4.1. AMD 64 will be the version that we'll go with. This is a 64-bit based system, so if you're using 32-bit, go with the i386 version. This is the one that we'll take. This will allow us, as we've already mentioned, for para-virtualizing hosts, not a problem. You can install across versions, so your host may be 32, hosting 64, not suggested, but is supported, and it does work. So this installs a 64-bit base version. Let's get this into the queue as well. Control-Shift-V to post that to this screen. And additional dependencies will be placed, including the QEMU or QME or QEMU, that is, dependencies which handle a variety of functions for us, including logging, but not limited to logging. So let's go ahead and tell it to install these various packages. Again, this does not update grub, but it does place the appropriate kernel for this version of Xen for this platform, AMD 64, which we'll have to update momentarily. So notice references above, found the Linux image, and it'll make it aware, update alternatives, Xen default. Now, Xen should be installed. Let's do an aptitude search. Xen, we should see a number of packages, Xen hypervisor 4.1, AMD 64. What's changed on the system? It seems as if it was too quick to be true. Well, if we do an ls, for example, boot, you'll see that there's the Xen image. So that's new to our system. The original kernel 23 is still there, and across updates the kernels are all Xen aware, so it's not going to be a problem. So peruse. So for A, for example, boot the following. This is the Xen kernel image, which needs to be referenced appropriately in the grub configuration. So install Xen, update grub. So that's going to be in our etc default grub file. It may be different on your distribution. Let's take a look at etc default grub. And this is where we can specify the default kernel. There's a grub default line, grub underscore default, that is. And that's default kernel, that is. This, including our comment of Linux CBT Classroom, just to be sure what we've touched, to a grub default equal to, between double quotes, this version of the hypervisor, which is simply Xen 4.1 AMD 64. This is just a front-end file, by the way, the etc default grub, that'll send the changes over to grub. And then once this is in place, we should then update grub using update grub to update the bootloader. That'll generate a new config file, which will allow us to default to grub. Optionally, you can modify the grub.config to have it load as well directly. Now at this stage, we're able to reboot the system now that the grub config, in fact, boot grub config has been updated, grub.cfg that is, to default to Xen 4.1 AMD 64. This is the version that's included. With our system, might be 4.2 or 4.0 on your system, depending. Just change it accordingly. So you could, of course, modify the boot grub.cfg default file directly, or the etc default, either or, as long as you instruct your bootloader that the Xen kernel should be the default kernel. Then we'll, once we've rebooted the system, have this new environment. Now before we reboot, some traces include etc-xen. This is an important directory. This is where the config files are located. This is where you'll normally place config files associated with your DOM-use. So as part of a perusal, B would be etc-xen. This is the primary config directory. And we should also note place DOM-U descriptors here. It's not absolutely necessary, but the tools by default will search etc-xen, so it's a good idea to place it here. The primary config file is this xend config sxp. You can peruse this to learn about some of the options that are applicable. So primary config file for the xend daemon. So for xend daemon itself, and that's in etc-xen. You can have a quick look at that. That's xend config sxp, and some logical things in here. Always will find information surrounding verbosity of logging, whether or not to listen to certain ports to offer certain services, such as, let's say, HTTP, perhaps, as an option, which some programs need. Maybe enable the Xen API server, SSL, secure sockets, etc. We're just going to go with the defaults for now. It even shows how networking occurs. DOM-U through the phony ETH0, through the virtual interface, onto the real interface, which is usually ETH0 on the main system, through the bridge, and so on. We're also concerned right now about the settings in this main config file. Here's a default VNC password file that can, or password entry. We're less concerned about this, more just about functionality, getting things up and running. Perhaps at another point we'll look into some of the details. But for now, we should be at a point where we can reboot the system. Another key directory, just so that you know, is in var log xen. You'll consult this directory often as well. It's currently empty because the system has yet to be instantiated with xen. So D, pay attention to var log xen. Once initiated, important log files will appear here. So have a look there as well. So we've updated grub, and of course, as part of updating grub, the next step, of course, is simply update grub. And this writes new boot config file in boot grub, grub.cfg. We're, of course, running the latest version of grub, version 2, currently 2x, so the config's more complicated than the original Xen. However, both are supported in either case, so long as Xen's included with the distribution that you're using, or if you download Xen, but it's easier when you use the package version. So now, let's go ahead and reboot. So reboot and confirm. We'll just kick that off. Drop our session, get a ping going just to see what packets come back over time. That should give us some feedback momentarily. Should come up with a Xen. If you're looking at the console, you should see a Xen menu entry to load the Xen kernel. Your system, the DOM0 space post reboot, will operate just as it did before, but now with the virtualization extensions, which allows the instantiation of the additional DOM-Us. So of course reboot, and let's just note, post reboot, system continues to behave as normal. However, original system is now represented via DOM0 with the ability, let's say, to provision DOM-Us or guests or VMs. And once we're at that stage, we should be good. But let's just take a look. Once this seems to be back up, let's SSH back into it. Let's fix this key issue. That's 2327. That should be somewhere towards the bottom, maybe. And that's this one, so it doesn't like 23 conflicting with 27. Let's see if we can get back in there. That's more like it. So the system's back up. Let's do a uname A. So it's still 3.20.23. As we've mentioned, kernels post the original version from Ubuntu 11, and since we're running 12.04, that's not an issue, all support Xen. So the kernel doesn't change. Just the context within the kernel for your administrative DOM0 changes, and that's it. And any kernel that supports Xen will function accordingly. So you don't even necessarily know that you're within a virtualized environment just yet. But let's take a look at some things that may be available. So take a look at var log xen. All of a sudden we see some entries. We can cat the contents, var log xen, xend log, and that'll show you how Xen came up, any issues. There are often many warnings, debugs that can be ignored. Sometimes you should look through if there are problems accessing services, but the key is that the daemon has been started. If we do a psef, let's say grep case insensitively Xen, we should see that xend is running. Now, Xen implements a number of services, and it uses Python's help to do so. The key one, of course, is xend, but it's constantly watching and checking for requests coming from, say, DOM-Us to service them accordingly for storage, networking, etc. So that's why multiple daemons appear under the name Xen or prefix Xen. It's busy looking at various items, but this is the key daemon, xend. That's the one that facilitates or instantiates, manages, allows us to start, stop, resume, destroy, etc. the various VMs. But more importantly, let's just note here, peruse Xen environment. And once we do that, one of the things we do is we take a look at the log file. So we cat var log xen xend log. ensure that Xen is started, do a psef grep Xen, and that shows the various Xen daemons. Let's just note that Xen D is primary daemon. However, there are other helper daemons for various functions such as networking, etc., moving information to and fro the various DOM views. But more specifically, tools that are associated with Xen management, for example, the XM-related tools or Xen-related tools. So, for example, XMinfo gives us information about the hypervisor. And this shows the primary host, the kernel that's running within the particular DOM0, that is the management kernel. More information. This is uname data that you can see. CPUs, the amount of memory resources, 8 gigs of memory, etc. So let's take a look at some of these important items. XMinfo dumps DOM0 details, which is a combination of uname as well as Xen-specific information. Uname giving kernel version 3.20.23. That's what we see here, plus the amount of memory on the system, which you'd get from others, plus CPUs, etc. So resources that are available for Xen. And the type of Xen running, x64 is the scheduler, x86-64 that is the scheduler. That's the version of Xen that's running. Now how about the actual DOMs? So XMList enumerates DOMs, or DOM0 through N. So DOM0 and DOM-Us. So DOM0 is always running. As long as you're able to access the system, it's always running. You cannot stop DOM0. It is the base or the core of the system which facilitates the functioning of all the other DOM-Us. So it shows you the memory as well as other functions such as CPUs, the state it's running, the amount of time that it's been in use, that is, of the CPU, etc. So it's up, it's running. We can't do much in terms of killing, stopping, starting, so on and so forth. So that's DOM0. XMList gives us that. Nothing, or XenList, by the way. So XenInfo, XenList, either or. So you can use XM or Xen. Let's just include that. So XM or XenInfo, XM or XenList. And for any of these commands, for the most part, you can use them interchangeably, XM or Xen. We use XM a lot. So what about the uptime of our virtualized environment? Well, there's, of course, a command for that, XM uptime. This is how long it's been up. You can compare and contrast it, let's say, to the main system. So the main system, 5 minutes, 29 seconds. They should reflect the same. 5 minutes, 38 seconds, DOM0 has been up. XM uptime. And of course, this is similar to data from plain old uptime, which gives you how long, so how long domain 0 has been running, which is the primary domain. And a number of other items. If you do XM with no options, you'll see the various items that are available to you, such as connecting via console or VNC viewer or create and so on. Many of these we'll be looking at momentarily, but the important ones for initial information include, but are not limited to, list, info, uptime. That gives you some basic details. Maybe even, for example, an XM top to see which domains are using the bulk of the resources on the node. So F will be XM top. There's a command Xen top, which is an alias to this, and this is a top, let's say, for Xen. So shows utilization across your domains, and it's all in the text, all in the shell, all text-based, so it's easy to follow. So this is domain 0, it's running, the amount of memory, CPUs, any limits on memory, etc. DOM0 is usually not limited. Individual domains are, which you'll see when we'll specify, so that you can facilitate or set aside resources for other nodes that are on the wire. You can start and stop Xen if you'd like and see how it impacts the main item, the main domain. So for example, etc init d Xen d, for example, status, and that doesn't come back with anything. Let's say we try to stop it and see what it does. Let's do an XM list. It says error connecting, but notice we're still up. The system's still running, but virtualization is currently not running. Now, individual DOM-Us can be configured to ignore the presence of Xen D. So individual DOM-Us can continue to run whether or not Xen D is running in the event that something kills Xen D, but your access from the client tools such as XM or Xen becomes disabled for the time being when you stop Xen D. So let's go back and start it and do an XM uptime, for example, and you'll see that it's still running. 7 minutes, 47 seconds, so it didn't break it or stop it in any means. XM list, still going. So let's just note, if you kill XenD, domain 0, DOM 0, or so let's just say DOM 0, and optionally various DOM U's will continue to run if they're configured to do so. You could, for example, configure the individual DOM U's to behave in different ways when domain 0 is terminated, or XenD management of domain 0 is terminated. But domain 0 is never really terminated unless the machine shuts down. Insofar as bridging, again, we should have that in place. If we had any issues, Xen would complain, but that's the bridge that will be used for our new node momentarily. That's still up and running. If config still shows that we're routing information through the bridge onto the main interface. XM list shows domain 0, amount of CPUs, its state, it's currently running. As it currently is reflected, we're started, we're running, we're going. Let's just make a quick word before we move on to individual DOM U's regarding the states. So let's say modes of operation, or let's say states, as reflected by XM lists when you dump it, or XM top, for example. So you'll note that the state information. So let's just drop the plurality. So these are various states. So modes of operation include basic sensible options such as R for running, for example. B for block, maybe something is blocking the running of a particular DOM, causing you to not be able to access it. Maybe you pause it like you can with any hypervisor, so pause. And let's just update this accordingly to P. And other common sense ones, so you might see shutdown in the event that you shut it down for various reasons, or maybe even crashed. Something might have crashed, and maybe a core dump, etc. These are the common states that you'll see in this area reflecting the current state of affairs. You're normally looking for R. Sometimes you'll see B for blocking in the event that you're interchanging the states regarding a particular DOM U. And that happens sometimes when you reboot or send a command using the XM. But just note that the XM is the main command for accessing it. So let's just note that XM or Xen are main front-end commands to communicate with the back-end XenD to overall influence the behavior of DOMs. That's what we use as the front-end client, XM or Xen. Insofar as linked, whether or not they are, so if you do a which XM, which Xen, LSL, let's say user sbin XM, and let's say Xen. And notice their pair 153, 43. The types will show that they're just scripts, they're not binaries. One maps off to Xen tool stack wrapper, the other one's just its own self, but they return the same options. If you do a Xen, you'll see the same options dumped. If you do XM, and it even reflects it in the command dump. So they're used truly interchangeably. So insofar as installation of Xen, just a quick recap, let's take a look at our steps. So the idea is that when you install Xen, it provisions in your boot on your primary system, your host, a new kernel, and that's a Xen kernel, and it's the version that's included with your distribution or one that you've downloaded. All kernels above, at least for Ubuntu 11x and higher, support Xen, so there's no need to change those kernels or to change the options or flag them to support Xen. They out of the box support Xen, so no problems there. The support's already built in. So this is Xen in and of itself. However, it isn't referenced automatically by grub, so that needs to be done. One way to do it on an Ubuntu Debian system is via etc default grub. So cat etc default grub, and we're able to tell grub to use a default kernel of this, which is mapped out, and it finds it accordingly. Once it finds that kernel, it boots up and it becomes a tier 1 hypervisor because it now has access to hardware, and it shifts the perspective of your original system into this privileged domain called domain 0. Perhaps that brings another point that we have alluded to mention, and that is that domain 0, or let's say DOM 0, domain 0, is privileged, whereas DOM U's, domain U's, or let's say guests, are unprivileged. And that's what the U actually stands for. So that's the big difference between privileged and unprivileged. So DOM0 is privileged, and PSEF grep Xen, through these various Xen commands such as bus, watch, XenD, storage, etc., console, we're able to access the hardware from the other DOM-Us. So it's a pass-through, if you will, from DOM-Us into, so from unprivileged domains into a privileged domain into the actual hardware. So that's how the pass-through takes place. So we install Xen, update grub the bootloader, unless you have a script that does it automatically for you, reboot, Xen's up, domain 0 is available, the bridge is still up, that looks good, ETH0 is accessible, resources are available, and now we're ready. We're at a stage where we can provision, as we've already mentioned, the two types of virtualized guests supported. Para-virtualized PVs, which are faster, however not as flexible, and HVMs, or hardware virtual machines, which are much more flexible, fully virtualized, provided with full BIOSes, appear just like what you'd see, let's say, within other commercially available alternatives such as virtual VMware's virtualized environment or virtual hypervisor, or any of their strains such as vSphere, ESXi, etc. So this is perhaps the mode that you'll use to have, let's say, a Linux host hosting maybe Windows and other operating systems such as Solaris, FreeBSD, and maybe Linux. And if you're strictly Linux, then maybe you'll use para-virtualize and contain them in that way. But either mode you go with, a sandbox is created, and they're essentially domains. So note, domains are basically sandboxes that do not have access to one another except the universal access to the management DOM, which is equal to, of course, DOM0. So the main kernel, the Xen kernel DOM0, brokers those connections. So the Xen is installed. That's it. It's rather simple. Let's move forward.